Bueno, buenos días a todos.
Good morning, everyone. Welcome to LACNIC event. I'm Ignacio Estrada. I'm Strategic Relations Manager, and I will be with you this morning. Before beginning, let me tell you that we have presentations in the three languages, English, Spanish, and Portuguese. So I strongly suggest that you, if you need it, pick up your devices, your headsets at the entrance to the room. So we will now start with today's activities. The first activity is Theory versus Practice, the Future of the Data Centers for Businesses and Persons by Michael Bouchong, whom I now invite to come up. He's Vice President of Cloud and Enterprise at Nokia. The presentation will be made in English, so I once again suggest you pick up your devices. So welcome, Michael.
Hello, folks. So my name is Mike Bouchong. I work at Nokia. I traveled into Brazil for the third time in the last 6 months. Thrilled to be down here in the Southern Hemisphere again. My colleague, Kadu, let's get him a good photo. Here, let's get this. Let's look like we're good? Okay. He assures me that if I make one more trip to Brazil, I'll be an official Brazilian citizen, and so I've been working on my Portuguese. Obrigado por devolver meu celular perdido was the latest thing I had to learn. Yeah. I did, in fact, lose my cell phone to start the day today, but a very nice Uber driver returned it. I want to talk today about where data centers are going, and I'm going to try to give you a practical point of view. Now, if you ask anybody where is data center going, you're going to start getting slides that look like this. Now, I don't entirely know what this picture is. I just Googled it and found it. But marketing people believe the future is digital. We believe it's fancy. It's lots of connected things that fit in your hand. I don't know that anybody actually deploys a picture that looks like this. Now, if you're more creative, you might use a word cloud. You might do something like, what are the technologies that are going to drive data center? And you're going to see things that look like this. The very center of this is artificial intelligence. AI is everywhere. You might hear it called different things, artificial intelligence or cognitive learning. You might hear things like machine learning, regression analysis. There's different ways we think about it, but this is not what people actually deploy. What I want to do today is talk to you a bit about what is likely to actually be deployed, what's going to impact your lives on a day-to-day basis. Okay, so if it's not a word cloud that has AI involved, is artificial intelligence going to be a big part of data centers in the future? Certainly, part of the answer has to be yes. If you look at what NVIDIA is doing with their GPUs, if you look at NVL72 and NVL36 and where they're going, the DGXs, the rise of AMD in the whole GPU space, it is absolutely true that our market is going to be at least influenced by artificial intelligence. But as much as the answer is yes, the answer is sadly also no. And why do I think it's no? Because who's actually deploying AI clusters today? Certainly it's the companies that you know about, folks like Amazon and Meta and Google and Microsoft. They're spending literally billions of dollars per year to build out AI infrastructure. Meta alone raised their CapEx estimates to $38 billion in 1 year so that they could keep pace with what's happening in AI. But outside of the top 4, 5, 6 different companies that are building out AI, there's only a handful of companies that are also building out large-scale training clusters. Companies like Grok and Anthropic, xAI, OpenAI, there's about 12 or 13 companies worldwide that are going to build out large-scale data center infrastructure to support big training for foundational LLMs. If that's the case, then what does that mean for everybody else? Now, In order to build that out, today, the current standard today, using like an NVL72, is 120 kilowatts per rack. Now, if you break that into an NVL36, these are just NVIDIA, kind of their half rack and full rack solutions. It's about 66 kilowatt per rack if you do 2 half racks, which is even more. It's 132 kilowatts for the same infrastructure. The challenge in AI data centers is going to be power distribution. How can you even build out a data center that supports 120 kilowatts per rack? Most people don't have access to that kind of underlying infrastructure. And on top of that, that's just one rack. If you look and say, well, how big are these data centers going to be? These data centers, it's no longer the case that we're building out 25 or 50 megawatt data centers, 100 megawatt data centers, even 200 megawatt data centers. There's already gigawatt data centers that are in production. They've broken ground on 2 gigawatt data centers. And I've personally talked to companies that are building out 6.4 gigawatt facilities to drive clusters. Now, that's not what most people in the world have access to. This is a very narrow set of companies that can even purchase the type of equipment and infrastructure required to do something like this. And that's before you consider changes. NVIDIA is already talking about a 600 kilowatt rack, one rack. And Google doesn't want NVIDIA to get all the news. They're talking about plans for 1 megawatt racks already. Now, how many of you have a data center that you could support a 1 megawatt rack? Not even one person? That's shocking. So a lot of the AI, a lot of the technology that's driving this isn't going to be something that changes the day-to-day lives of people who operate day-to-day data centers. So does that mean that there's going to be nothing in the AI space for anybody not called Google, Meta, Microsoft? I don't think that's actually true. There is a use case around inferencing. For those of you who spend any time in the technology space, you'll know that kind of what inferencing is. A lot of it is used to do things like auto expansion and fine-tuning search. When you do that, inferencing actually leads to an entirely different use case. Inferencing is going to favor more broad distribution because things like performance and latency actually matter. Inferencing is going to happen at the edge, so you'll see distributed data centers. You'll see edge cloud will start to become a real thing because there's a real use case that gets tied to it. You'll even see inferencing happening in the handset. Last year, Apple made announcements around their M3 chip being used. Essentially, they're going to sell that chip and they're going to bring their MacBook compute power into the handheld, into your phone. The whole idea is that you can intercept the inferencing use case. Now, when this happens, what you're going to see is distributed data centers running an architecture that's closer to like a collapsed core. For those of you not familiar with data center architectures, a collapsed core is merely a half rack up to maybe 2 racks, sometimes 4 racks, running, kind of collapsing the leaf and spine together into a single layer. And when we do this, the footprint becomes much smaller. Inferencing doesn't require the latest GPUs, and so you can use generations that are maybe 1 or 2 generations past. And this means that you'll start to see this portion of the AI use case take off essentially globally, because if any users want to take advantage of AI, they're going to need to have something that's closer to home, something that is not a big, giant, massive, centralized data center. So here in Brazil, when you think about kind of the distribution of the ISPs, a lot of the colo facilities, the neutral host data centers, this starts to bring a lot of that closer to where everybody is. And so you will see AI have a durable, kind of a lasting impact on that part of the market. Now, if we're not going to build big training clusters everywhere, certainly AI is going to impact everything we do, right? You may not have to build the training cluster, but the technology itself is going to be transformative. Everybody's going to touch it. Like, that has to be true, right? Well, certainly there's some truth to that. Absolutely, people will use AI models. We'll see AI transform common everyday applications. We'll see AI changing the way that we interact with technology of all kinds. But actually, part of it's not true. Some of the AI hype that's there today is a little bit overstated. When you listen to people talking about the future of AI, part of what they're doing is they're building up the possibility. There's been a giant gold rush going for, kind of trying to build AI things, and the strategy that many companies have looks a little bit like this. Now, this is a screenshot from a US television show called South Park, and in this episode, they had what they called the underpants gnomes. I don't know how that's going to translate. But the underpants gnomes had a business they had a business theory. They said, we're going to collect underpants. Step 2, we don't really know. Step 3, profit. Okay? That's a little bit like what we see with AI. Step 1, let's do some AI. Step 2, we don't really know what we're going to go do. Step 3, we're going to make a lot of money from that. Now, we have to see if that's actually going to bear fruit, if that's going to be something that actually happens in most companies. Sadly, what most companies are seeing today, if you look at enterprises, we're seeing huge failure rates of their AI projects. When AI came out, a couple of years ago, when ChatGPT was sort of the pinnacle of all things artificial intelligence, every company in the world had pressure from their board of directors asking them the basic question, what are we going to do with AI? And the answer was, frankly, let's start some project. And everybody built some GPT derivative, and they decided they were going to put that into their products. What's happening now is that people are finding out that the link between an AI project and actual profit is not as direct as you would think. And I want to give you a simple example. Certainly AI is going to impact medical imaging. When you think of X-rays or MRIs, we're going to use AI to go and analyze the pictures to diagnose the problems that exist within our patients. Does that mean that people are going to make a lot of money from medical imaging AI applications? Probably not. You see, anyone who's getting their master's in university is going to write their first AI application to look at something like medical imaging because the data is pretty easy to get. And so if you have 50 different applications that all do medical imaging analysis, it's not the case that AI makes a lot of money. AI will absolutely change the industry, but all 50 of those applications are going to get basically $0 in revenue. And so AI, as an enterprise ambition, what we're going to find is that there's fewer companies that are able to put this into practice, which means that AI won't necessarily have the business transformation that we expect, even if it does improve the lives and the function of applications and people. Well, certainly if that's true, that's a little bit disappointing. But within networking, the future of data centers should be self-driving cars, right? We should have a self-driving data center. And again, the answer here is there's some truth to that. I think it's absolutely true that we can use technologies like AI ops to drive improved data center operations. But there's a little bit of, let's say, marketing hype that's being pushed into the AI ops space to make some of it less likely to land. And so if we want to predict what the future of data center is, we need to understand what's true and what's likely to impact day-to-day operations. I lost my down screen. There we go. So when you do day-to-day operations, we have to answer the basic question, are our operations deterministic? Effectively, do we do the same thing over and over again in the same situation? Or are they stochastic? Do we look at probabilistic things, in which case we have to get access to information and then assess what's the right thing to do next? Now, for most people who talk about AI ops, the number one use case is typically optics failures. If you have a large number of optics in an environment, we want to use AI to do dynamic thresholding. We want to look at kind of performance of individual optics and assess where failures are likely to happen. That use case makes a lot of sense. Now, most mathematicians would tell you that that's not really AI, that's more like linear regression, but that is a useful use case. Beyond that, though, when we start looking at are we going to be able to look at a bunch of different conditions that exist in a complex environment where each environment is different, right? Every environment, even the same network in two different contexts, is going to be very different. The information's different, the baseline is different, and so it's very difficult to have fine-tuned models that can reach very specific conclusions in that kind of environment. And so it's more likely from an operations perspective that we'll use things like rules engines, where you might have a workflow engine, and you might have an event engine, and you want to feed information in, but you want to work things through a more determined path so you can get to a specific outcome more quickly. Let me give you a non-technical example. Years ago, when I was at work at a different company, I was in the break room. I had a spare hour where I had no meetings, and I sat there around lunchtime, and I watched person after person walk in and put their food into the microwave and push the buttons, and the microwave didn't work. And every single person went through, the first thing they did was they would open the door, they'd close it again. So first thing you do is you reboot it, see if it still works, right? The next thing you do is they went and they grabbed the power cord, because when something doesn't work, the first thing you do is you check layer 1. That's a deterministic path. Everybody wants to do the same basic workflow, and in that environment, AI might be the right tool, but more likely what you need is a set of technologies that are similar and might leverage AI, but are really baked more in where do I get my telemetry from? What's my basic rules engine look like? How do I orchestrate activities over a diverse set of information or a diverse set of devices in a multi-domain environment so I can do end-to-end troubleshooting? Now, that's not to say that I don't think AI will have an impact. I actually do. I think AI is what I would consider a durable technology. I just think that the future of AI, especially in a networking context, is going to be more around like agentic AI. It's not going to be that humans are replacing, or that machines are replacing humans. It's going to be more closer to the co-pilot model, where we use agents that exist either on box or in orchestration layers above. And then we use those to essentially make recommendations so that we can get to faster insights in a real-world environment. Now, in this agentic era, there's a couple of things that really matter. The first is, do we have access to rich information that allows the agents themselves to draw conclusions? Here, we'll use foundational models. Large LLMs will be a part of it. But the truth is that the narrower you get, the more specific you get around fine-tuning, that's going to give you a much better outcome because, as I mentioned earlier, every network is different. In this environment, then you don't expect that vendors will necessarily sell you a thing that here's my agentic AI solution that's very specific to your environment. What you have to start to do is to develop some of that expertise in-house, because the information that you have within your own environment is going to be what allows you to fine-tune the models and get to very specific outcomes in your very specific network. The second thing, if the goal around agentic AI is to derive insights, not only must I have telemetry, I want to then automate the outcomes that come out of that. And so you'll need to see integration of a lot of the automation infrastructure that supports operations more broadly. Now, this part's actually very, very difficult because most people from an automation perspective treat their automation primarily around configuration management. It's mostly around provisioning. Things like Ansible and Terraform are good examples. And so if we want to move to where agentic AI is having a huge impact on things like troubleshooting, what it forces us to do is to build out workflow that's multi-domain, which means the integration of different systems that sit above the network. Whether that's tools like Netbox or Nautobot as an example, whether it's provisioning tools or workflow tools like ServiceNow or OSS, BSS tools, it means that there will be a burden on how we integrate this in a real-world environment. And this means that the tangible day-to-day benefits that come out of agentic AI will not be dependent on merely producing agents, but on integrating those agents into a real-world environment. Now, if you're a company and you're looking at all of this change, then the next question is, well, what do I do to take advantage? And I'll tell you, there's some basic things that people need to do. When we move to cloud, so I'll go back to kind of the early cloud days, the first thing companies did when cloud got here was they did a lift and shift and moved applications into the cloud. The thing that was really important, and frankly very dangerous, was that they gave up control, architectural control and oversight of their environments. Now, when you give up control, what we saw then was that if Amazon East went down, and then your entire enterprise would go down because you hadn't looked at like geo-redundancy inside Amazon. When you give up control, you lose control or influence over the eventual outcome. As AI comes in, we need to make sure that we don't give up control to the vendors that are talking about the glorious impacts of AI, because you're going to be the one that has to deal with the repercussions when things go wrong. The second thing, if AI ops is going to be transformative in real-world data centers, it's going to be an operations story. And if it's an operations story, you're going to need surrounding infrastructure that supports it. I would start, if you're not already deploying workflow and event engines, and there's different commercial and open source versions of these, I would get very deep into workflow and event engines very, very quickly, because this is what's going to drive your ability to get to orchestrated outcomes. I would raise operations generally to a first-tier consideration. Most people, when they think about like issuing the next RFP or the next RFQ, typically what they do is they start with the underlying architecture. What devices do I need? What software features are going to be important? What port speeds are going to drive my connectivity in this particular area? You've got to also have a particular point of view around what are your operational requirements. What telemetry interfaces am I going to use? How am I going to integrate that? Am I going to have a central message bus that's going to, in a pub-sub model, and if so, how is that integration going to happen? Am I relying on SNMP, or am I looking at things like GNMI and gRPC? Different technologies will give you different outcomes, and elevating those decisions to top-tier considerations will give you a much different outcome going forward. Then you've got to realize that the operations are going to impact how you do hiring. So network engineers, now nobody in this room is getting older, but I am. I turned 50 years old this year. Network engineers, as we get older, we will exit the workforce. And when we exit the workforce, who's going to replace us? Is the next group of network engineers going to come out of university with a networking degree and lots of experience, a Cisco certification maybe? Like, is that the next-gen networker? Probably not. The next-gen networker is going to come out of university with experience in cloud tools. They're more likely to know what Grafana and Prometheus are than they are to understand, some of the networking things that we've talked about for ages. And if that's true, then you need to start adjusting your operations now so that when they come in, they can actually be useful in that environment. If a network requires a vendor certification to operate, the pool of vendor-certified individuals gets smaller, and so it becomes very difficult to actually grow and carry things forward. And on top of that, the next-gen tools will perform better than the last-gen tools. So not only will you build an expensive workforce, they'll actually be less effective than the newer workforces coming in using newer tools. And those newer tools will be focused on a newer interface. Natural language will be the interface that is more common, and so if that's true, getting experience with natural language interfaces now is something that's very useful because it'll change the way that you interact with your infrastructure, both from a provisioning perspective, but also from a monitoring, observability, and troubleshooting perspective. Now, that's how companies manage this. How do individuals manage the change? Now, in our industry, there's a very dangerous dialogue. We position things like automation and artificial intelligence as a threat to individual jobs. Now, in some cases, maybe there's some truth to that. I already said that I believe the future is technology and humans. I think we need people need to prepare to work alongside the technology. And there's specific things that I would tell you that you should do now. You've got to remember the basics. Certifications are useful in that they force us to understand how protocols work, how architecture works. It forces us to think through how do we want to design a network and operate within that environment. The memorization of the commands, less useful. Your certifications aren't necessarily going to save you, but the basics, the foundational information, that's going to drive your relevance in the go-forward environment. I would start to get used to some of the agentic AI bits now. I would start with basic research. There's all kinds of simple open source tools. I would get comfortable in that environment because the more comfortable you are with how that environment works, the easier the transition will be, and you'll be in a position where you'll be one of the few people who can take the deep experience necessary to understand a network and combine it with modern tooling. People who come out of university with an AI focus, they don't actually generally know network engineering. So combining that puts you in a very unique position that will drive unique value in your company, and I would argue very unique value for your own career. Now, the underlying premise of any operational transformation is very simple. You see something, then you do something, which means understanding modern telemetry is going to be huge. You need to understand how telemetry works. There's, if you had to choose, if you're doing SNMP today, stop, move closer to GNMI and gRPC. They will get you further along. There's a lot that happens in that space that will give you access to next-gen things. And then the interfaces, I mentioned NLP, start looking at interfaces today because if you're familiar with the tools, you'll be in a stronger position to take advantage of them. Now, the last thing that I'll kind of remind you of, if I were to ask today, how many of you, your number one pain point in your network today is I don't have enough AI in my network. Please solve that pain point. That's actually not how people manage networks today. The number one thing that people want is it just works. I want data centers that actually they work. I don't want to deal with software issues, configuration issues. I want to be able to do proactive analysis using digital twins because I need to make sure that these things just work. Second, it's got to be easy to use. This gets into kind of the whole operational transformation. And if we're being honest, it's got to be affordable. When you look at these things, it means that a lot of the impact that we're talking about from a marketing perspective is really beyond what people are actually going to do. And so I'll close with this. It could be that the future of data center is a wild party, that the new fancy technology is going to drive exactly where we're going, that the next buzzword, the next event speech that comes up, and I don't know who's talking next, so hopefully they're not going to say any of this. Or it could be that the future of networking is going to be what I call boring innovation, things that actually just help your day-to-day. My belief fundamentally is that the future of networking is going to be that the marketing may set the direction, but the thing that's going to drive adoption does it matter in your day-to-day. And the things that we have to do in our day-to-day are far more routine than we like to admit. The future of data center, frankly, will use things like AI, but it's going to be grounded in day-to-day, how do I manage my ongoing infrastructure? My name's Mike Bouchon, I'm at Nokia, and this is how you look at data center. Thank you.
Thank you very much, Michael. Great presentation. Love that South Park picture in your slides. Bueno, vamos a seguir con la